the percent concentration of a drug in the bloodstream X hours after the drug is administered is given by K of X equals 4X divided by the quantity 3X squared plus 27. On what interval is the percent concentration increasing? We want to know this because if the concentration is going up in the blood, that tells us that the effect of the drug should be starting to take place. So the first thing we need to do is take the derivative, and we'll do that with u and v, and apply the quotient rule. So the first piece you see in the derivative, 3x squared plus 27, is my v, times 4, that's the derivative of 4x, minus 4x, which was u, times the derivative v prime. Well, the derivative of the bottom part here is 6x, and on the bottom we have v squared. Let's do a little bit of simplifying on that. So I'm going to go ahead and I'm going to distribute the 4 into each one of my terms. That gives me 12x squared plus 108. When I combine the pieces in this second term, I get minus 24x squared. I notice that there's some like terms here, so when I combine 12x squared and minus 24x squared, it gives me minus 12x squared plus the 108 that was there when I distributed the 4 onto the 27. To find the critical numbers, I need to either set this equal to 0 or find where it's undefined, which means I'd have to check where the bottom's equal to 0. But when you look at that bottom, 3x squared plus 27, that's always positive because x squared is positive. 3 times that's going to be positive. Adding 27 means it can't be 0. Squaring it is going to make it even more positive. So this bottom can never be 0, so the only critical numbers is going to be where the top is 0. So let's rewrite that, and now let's factor that top out. So it looks like I can factor out a 12. So I'm going to actually pull out a minus 12. Minus 12 times x squared gives us minus 12x squared. Minus 12 times minus 9 gives us the plus 108. So this factors as minus 12 times the quantity x squared minus 9. You should now recognize that this second factor is a difference of squares, and it factors as x plus 3 and x minus 3. So that's going to give us two critical numbers, where each one of these two factors on top are equal to 0. Now when I make up my number line, I've neglected to put the negative 3 critical number on here. And the reason for that is because negative 3 is outside the domain of what would be interesting for this. Remember, x represents hours. Negative hours in this problem doesn't make any sense, so we're really going to start everything we do here from 0 and go to the right, so we're talking about positive number of hours. So when I test this, I'm going to have to test in the interval from 0 to 3 and from 3 to infinity. So let's pick 0 and 5, and we're going to test that into our derivative. So when I put 0 into the derivative, the bottom, like we said earlier, is always positive. We have negative 12, 0 plus 3, that's positive. 0 minus 3, that's negative. So negative 12 times a positive times a negative divided by a positive is going to be positive. So on my number line, I'll put a plus. Now let's check at 5. So when I put 5 into each one of these factors, I get negative 12. 5 plus 3 is positive. 5 minus 3 is positive. The bottom's positive. So negative 12 times positive divided by positive is negative. So on the right-hand side of 3, we get negative. So our derivative is positive from 0 out to 3, and then negative from 3 to infinity. That means that it's increasing from 0 to 3, and we included 0 on this because the derivative was positive there, and it's decreasing from 3 to infinity. The derivative was positive where it was increasing, it was negative where it was decreasing. If I go ahead and look at a graph of this, I can see exactly what we just said. The drug is increasing in concentration very steeply until we get to 3, where it levels off. The critical point is where the derivative is equal to 0, so we have a tangent line here that would have a slope of 0. Then after that, it decreases forever and ever, and eventually it'll come down alongside an asymptote that lies along the x-axis.